What do you do when the one road your entire war machine depends on suddenly stops existing? For years, Iran built its defense around a single assumption. That road would always be there. That assumption just got tested, and it failed in less time than it takes to drink your morning coffee. Before we go further, smash that like button right now. Hit subscribe if you're new here, and share this with someone who thinks modern warfare is still about tanks rolling across open fields. It isn't. It's about roads, tunnels, and timing. Let's break down exactly what happened. To understand why this strike matters so much, you need to understand something most people never really think about. Militaries don't run on soldiers alone. They run on supply lines, fuel, ammunition, spare parts, food, medicine. All of it has to move from where it's made or stored to where it's actually needed on the front lines. And in a country like Iran, with mountains splitting the landscape into isolated pockets, that movement often depends on just a handful of critical choke points. Roads, bridges, tunnels. Take away enough of those, and it doesn't matter how many missiles you have sitting in a warehouse somewhere far inland. If you can't move them to where they're needed, they're effectively useless, no different from having no missiles at all. Iran understood this reality better than almost anyone in the region. Decades of sanctions and international isolation had taught its military planners to build redundancy into everything they could. Multiple supply routes where possible, hardened storage facilities, backup systems for the backup systems. But even the most careful, patient planning has weak points, and every weak point eventually gets found by someone determined enough and patient enough to go looking for it. The target at the center of this story was a mountain tunnel system feeding one of Iran's most important ports. Picture a narrow strip of coastline where nearly a quarter of the country's entire trade passes through on its way to the rest of the nation. Now picture almost all of that trade squeezing through just 2 routes north. One tunnel cut directly through solid rock, one bridge spanning a deep river gorge. That's it. That's the entire lifeline for a massive share of Iran's economy and a significant portion of its military logistics network. Lose those 2 routes, and you don't just inconvenience a busy port. You choke an entire region's ability to function at all. That's exactly what made this target so valuable to strike, and exactly why Iran had spent years building layers of defense specifically to protect it from exactly this kind of scenario. Radar installations, positioned along the coast, surface-to-air missile batteries stationed on the high ground overlooking the approach routes, mobile defense systems parked close to key infrastructure for rapid response, communication networks linking everything together so that a threat detected in one place could trigger a coordinated response somewhere else within seconds. On paper, this was one of the most heavily defended stretches of territory in the entire country. In practice, it turned out to have a fatal flaw that nobody inside that defense network fully appreciated until it was already far too late to matter. Here's where the story really begins. In the hours before dawn, a small formation of aircraft approached from open water south of the Iranian coastline. This wasn't a massive strike package involving dozens of planes roaring in together. It was a small, tightly coordinated group built around stealth fighters designed specifically to avoid detection, supported by additional aircraft carrying a very different kind of weapon entirely. Not bombs meant to flatten buildings, but missiles designed specifically to hunt down and destroy enemy radar systems themselves. The entire plan depended on one simple, elegant idea. Blind the network before it can meaningfully react, then strike the actual target before anyone left in that network can warn the people responsible for defending it. The first sign that something unusual was happening reached an Iranian radar operator working at a coastal installation designed to detect exactly this kind of approach from the sea. This wasn't an ordinary short-range radar system either. It was a long-range installation capable of detecting aircraft hundreds of miles out, bouncing signals off the upper atmosphere and letting them curve back down far beyond the normal visible horizon. In theory, that gave Iran an enormous early warning advantage over any incoming threat. In practice, that kind of extreme long-range detection comes with a serious, unavoidable trade-off, built right into the physics of how it works. The further away you can see something, the less precisely you can actually pinpoint exactly where it is in real time. A contact detected at extreme range might only be accurate to within 20 or 30 miles in any given direction. That's not a targeting solution anyone can act on with confidence. That's barely even a starting point for further investigation. Still, it was enough to trigger a response somewhere down the chain of command. Word passed along through several layers of communication, and closer to the actual coastline, a far more advanced air defense battery began preparing to engage whatever was coming. This wasn't some outdated relic pulled out of storage either. It was one of the most capable surface-to-air missile systems Iran possessed anywhere in its arsenal, a system purchased specifically because of its strong reputation for shooting down exactly the kind of advanced aircraft that might attempt a raid like this one. Powerful engagement radar, long-range missiles capable of incredible speed, a crew trained for years to operate exactly this equipment under exactly this kind of high-pressure scenario. But there's something important to understand about modern stealth aircraft that most people watching from the outside never really grasp properly. Stealth doesn't mean invisible. It means difficult. It means the aircraft is shaped and constructed in a very specific way that scatters incoming radar energy away from the direction it originally came from, rather than reflecting it straight back toward the radar dish the way a normal, conventionally shaped aircraft would. From certain angles, a stealth fighter can appear on radar barely bigger than a small bird flying past. From other angles entirely, that same exact aircraft becomes far easier to detect and track, which means everything comes down to angle, timing, and absolute pilot discipline. Fly the wrong heading at the wrong moment, even briefly, and you suddenly become visible. Hold your line with perfect precision, and you remain effectively a ghost the whole way through. That's exactly what the incoming pilots did throughout this approach. They held their flight path with absolute precision, keeping their aircraft angled in a way that minimized what any radar system on the ground could actually pick up and confirm. The defending battery caught only fragments, flickers, faint, inconsistent returns that shouldn't have even been possible according to their own training manuals and years of doctrine. Professional crews don't simply ignore uncertainty like that when lives and infrastructure are on the line. They act on the best information available to them in the moment, so a missile launched from the battery, screaming skyward on a bright plume of exhaust, writing a guidance link back to the ground radar that had detected the faint, uncertain contact in the first place. That missile detonated over open, empty water. It missed by a wide enough margin that it never came remotely close to the actual formation flying past. Expensive, sophisticated, and completely wasted in a single instant. Not because the missile itself was somehow flawed or malfunctioning, but because the target it had been chasing was never actually where the ground radar believed it to be. The gap between rough detection and precise targeting had done exactly what it always threatens to do under real combat conditions. It turned a very expensive, carefully engineered weapon into a very expensive mistake, gone in a matter of seconds. But here's the part that mattered most for everything that happened next. That missile launch told the incoming aircraft something incredibly valuable about their surroundings. It told them exactly where that particular radar was actively transmitting from. And that is precisely the kind of information a very specific type of weapon system is built from the ground up to exploit ruthlessly. Riding alongside the stealth fighters, 2 additional aircraft carried anti-radiation missiles, weapons specifically engineered to home in directly on radar transmissions and destroy the source responsible for emitting them. The moment that Iranian battery lit up its engagement radar in order to search for a viable target, it effectively broadcast its own precise location to anyone listening carefully nearby. And someone absolutely was listening. Within moments, a missile launched from one of the support aircraft, tracking the radar signal itself directly, rather than relying on any visual or thermal signature to find its target. There was no realistic way to hide from it once the radar stayed actively transmitting, and shutting the radar off completely at that critical moment would have meant giving up any remaining chance of finding and engaging the incoming aircraft at all. It was a trap with genuinely no good way out for the crew operating it. The missile found its intended target without hesitation. The radar dish that had served as the eyes of that entire battery was destroyed in a single devastating strike, along with the crew's ability to guide any further missiles with meaningful precision going forward. A defense system worth tens of millions of dollars, rendered completely useless by a single weapon, costing only a small fraction of that original price. And, in a coastal region with limited backup coverage available, that particular loss wasn't something that could simply be patched over quickly in the middle of an unfolding crisis. The gap it created in coastal defense coverage stayed wide open for the rest of the operation. If this kind of detailed breakdown is exactly what you come here for, now's a genuinely great time to hit subscribe. New breakdowns like this one drop regularly, and you really don't want to stumble onto this channel late and end up missing the ones that came before this. Alright, let's keep moving forward, because the story only gets more interesting from here. While that entire radar duel was unfolding along the coast, a completely separate part of the wider operation was already quietly in motion elsewhere. Somewhere off the coast, a naval vessel launched a cruise missile aimed not at any weapon system directly, but at critical communications infrastructure instead. This is a detail that often gets overlooked entirely in stories about airstrikes, but it might genuinely be one of the most important pieces of the entire coordinated operation. Modern air defense doesn't just depend on radars and missiles sitting in isolation. It depends heavily on the wires and relays connecting everything together into one functioning whole. A radar that spots a threat somewhere is completely useless if it can't quickly tell a missile battery exactly where to look and when to fire. That critical communication has to travel somewhere physical, whether through buried underground cables, microwave relay towers positioned across the terrain, or coordinated phone lines linking together regional command centers spread across the country. The cruise missile struck a key communications hub directly, severing a critical link somewhere in that larger chain. Suddenly, air defense batteries scattered along that entire stretch of coast weren't operating as one single coordinated network anymore. They were isolated islands instead, each one relying entirely on its own local radar coverage, with no meaningful early warning coming from anyone else nearby, and no coordination whatsoever with neighboring units positioned just a short distance away. Imagine an entire team where everyone suddenly loses the ability to talk to each other in the middle of a genuine crisis. Each individual person keeps doing their assigned job as best they can, but nobody actually knows what anyone else nearby is seeing on their own screens, and reaction times across the whole network slow down dramatically as a direct result. That's exactly the kind of chaos this single, well-placed strike created, all without a single fighter jet needing to fly anywhere near that particular communications target itself. With the wider network now fractured and one major radar installation already destroyed, the formation continued pressing forward on its approach toward the actual primary objective. But the layered defenses weren't finished presenting obstacles just yet. Closer to the final target sat a much shorter range, fully self-contained air defense system. Unlike the long-range battery that had just been destroyed minutes earlier, this particular system didn't depend on any outside communication links at all to function. Everything it needed to operate, search radar, tracking radar, and a full complement of ready missiles, rode together on a single mobile tracked vehicle, fast to react, genuinely difficult to avoid at close range once engaged. A guard dog sitting right at the gate, sharp-toothed and alert, positioned directly in the flight path leading toward the final target. As the aircraft entered its effective detection range, an alert tone suddenly sounded inside the cockpit. A radar lock had been achieved on the aircraft. In a situation like that, every natural instinct might scream to break away immediately, to dodge violently, to do literally anything, except hold a perfectly steady course while an enemy missile system actively tracks your exact position in real time. But the pilot held steady regardless, trusting the aircraft's built-in countermeasure systems to do exactly the job they were designed and tested to do. Modern stealth fighters don't just rely on their physical shape alone to avoid detection and engagement. They carry sophisticated electronic systems specifically designed to detect an enemy radar's signal the instant it first arrives, and respond immediately with a carefully manipulated return signal, essentially feeding the enemy radar a convincing, well-crafted lie about exactly where the aircraft actually is positioned at that moment. The trick worked exactly as it was designed to work. The tracking system on the ground suddenly began showing physically impossible behavior from its supposed target, sudden and completely unrealistic changes. In position that no real physical aircraft could ever actually perform in real life, faced with a track that no longer made any logical sense whatsoever, the operator hesitated at the controls. Standard doctrine in situations exactly like that calls for holding fire rather than wasting valuable limited missiles on a track that has clearly become corrupted and unreliable. That brief hesitation, lasting only a handful of critical seconds, was ultimately enough to make all the difference. The aircraft passed completely through the danger zone without ever taking a shot fired directly at them with any real confidence behind it. With that final layer of immediate close-range defense successfully neutralized, the formation finally reached its final approach toward the actual physical target itself. This is where things shifted decisively from pure evasive maneuvering to pure technical precision. The entire mission depended on hitting very specific points across two entirely separate structures at nearly the exact same precise moment. Not because of any dramatic sense of theatrical flair, but because of simple, unforgiving physics. Certain kinds of severe structural damage only happen when multiple explosions occur close enough together in both time and space to genuinely compound their combined destructive effects, rather than simply happening as separate, isolated, individually survivable events. Modern precision-guided weapons don't rely purely on a pilot's own eyesight anymore the way they might have decades ago. Advanced radar systems built directly into these aircraft can generate incredibly detailed maps of the ground below in real time, precise enough to clearly distinguish between natural rock formations and man-made poured concrete structures, all without needing clear visibility or even actual daylight to work properly. That detailed mapping data feeds directly into the guidance systems of the weapons themselves before release, giving each individual bomb an extremely precise target location already programmed in before it's even physically released from the aircraft carrying it. The specific weapons used in this kind of coordinated strike aren't simple, unguided bombs falling in a predictable straight line toward the ground. They're equipped with sophisticated guidance kits combining satellite navigation together with internal inertial sensors that can maintain solid accuracy even if satellite signals get jammed or otherwise disrupted during the final approach. Once released from the aircraft, these weapons glide for miles through the air, using small, thin adjustments to steer precisely toward their programmed target coordinates, ultimately arriving within a very tight margin of error, even after traveling a significant distance from the original point of release high above. And there's another critical detail that clearly separates these particular weapons from a standard, conventional explosive bomb. Some are specifically designed from the ground up for penetrating hardened structures, rather than simply exploding immediately on impact with the surface. Instead of packing a large amount of explosive material into a relatively thin outer shell, these weapons instead use a much smaller explosive charge wrapped tightly inside an extremely dense hardened steel casing. The actual goal isn't to create the biggest possible explosion right on the surface. It's to punch cleanly through multiple layers of concrete and solid rock first, and only detonate once safely inside the structure actually being targeted. A built-in delay mechanism inside the fuse ensures the explosion happens at exactly the right calculated moment, well after penetration has already occurred, rather than triggering immediately on the initial surface impact. That specific distinction matters enormously when you're trying to genuinely destroy something like a heavily reinforced mountain tunnel. A tunnel arch is engineered from the start to handle enormous pressure, pushing steadily down from above. Essentially, the weight of an entire mountain resting on it continuously for decades without ever failing. But that exact same structure turns out to be far weaker when the force instead comes from the opposite direction entirely, an explosion pushing outward from somewhere within the tunnel itself. Structural engineering that holds up incredibly strong against one particular kind of force can become catastrophically vulnerable against a completely different kind of force entirely. When the weapons finally struck their targets, both ends of the tunnel system collapsed almost simultaneously within the same brief window. On one side, the surrounding rock face gave way entirely and immediately, burying the tunnel entrance under an enormous amount of freshly collapsed stone and debris. On the opposite end, the force of the explosion, trapped tightly within the confined space of the tunnel itself, created a powerful shock wave that had genuinely nowhere safe to vent outward. Two separate blast waves, each one starting from opposite ends of the tunnel simultaneously, traveled inward toward each other and eventually met somewhere near the middle, briefly combining their destructive force together before the entire structure finally gave way completely and collapsed inward. At nearly that exact same moment, a separate coordinated strike targeted the second critical route leading out of the region, a bridge spanning a deep river gorge that served as the only meaningful alternative path heading north out of the area. That structure also collapsed completely, severing the second and final route in a matter of moments, right alongside the first. Within just a few short minutes, both critical supply routes leading out of one of Iran's most important coastal regions had been completely and thoroughly severed. Not merely damaged, not just partially blocked or restricted, genuinely physically severed in a way that would take enormous amounts of time, resources, and skilled engineering effort to ever properly repair. Let's pause here for a second, because this is exactly the kind of moment genuinely worth sitting with for a while. Drop a comment down below and tell me honestly, before watching this video, did you know that a small handful of aircraft could effectively shut down an entire region's supply network in under an hour without a single ground soldier ever crossing any border? Most people naturally picture wars being fought with massive armies moving slowly across open territory. Very few people ever picture it happening this precisely, this quickly, and this quietly instead. Now let's talk honestly about why this particular target mattered so much strategically, because the real significance here goes far beyond just one tunnel and one bridge sitting on a map somewhere. This wasn't some random, arbitrarily chosen stretch of infrastructure picked at will. It was the single lifeline connecting one of the country's largest and most economically important ports to the rest of the entire nation. Every container ship arriving loaded with goods, every tanker delivering desperately needed fuel, every truck loaded with military supplies destined for forces stationed further inland, all of it depended entirely on these exact two routes to move north efficiently. And there was no meaningful third option available, no convenient detour waiting nearby. The basic geography of the region simply didn't allow for one to exist at all. Think carefully about what that actually means in practical, real-world terms. A port can be completely full of ships, full of valuable cargo, full of everything a country genuinely needs to keep functioning smoothly. But if there's no reliable way to move that cargo away from the coast, none of it actually matters in the end. It just sits there, effectively trapped, while the rest of the country waits helplessly for supplies that can no longer reach them through any efficient available route. Alternative paths technically existed somewhere on paper, but they stretched for hundreds of additional miles through terrain poorly suited for heavy transport vehicles, turning what should have been a short, routine trip into a dramatically longer, slower, and far more vulnerable journey overall. For a military already stretched genuinely thin by years of sustained economic pressure and prior armed conflicts, this kind of sudden disruption isn't just mildly inconvenient. It's genuinely crippling to overall operations. Every piece of equipment, every shipment of fuel, every resupply of critical ammunition meant for forces stationed further inland suddenly faced weeks of unexpected delay instead of the usual matter of days. And in modern conflict, delays exactly like that can end up being the difference between forces that remain adequately supplied throughout and forces that simply run completely out of what they desperately need at the worst possible moment imaginable. There's also a genuine psychological dimension to this kind of devastating strike that's just as important in the long run as the immediate physical damage itself. For years, Iranian military planners had operated confidently under the assumption that this particular route was thoroughly secure, heavily defended, layered carefully with radar coverage, missile batteries, and redundant communication systems specifically designed and built to prevent exactly this kind of scenario from ever happening. That confident assumption had shaped years of careful strategic planning, ongoing logistics decisions, and overall resource allocation across the military. Watching that entire assumption collapse within the span of a single early morning operation sends a message that goes far beyond just the immediate physical damage inflicted. It tells an entire military leadership structure that their most carefully protected assets are simply not nearly as secure as they had genuinely believed for years. That kind of deep psychological impact tends to ripple outward afterward in ways that are genuinely hard to fully measure or contain. Confidence in existing defense systems takes a serious, lasting hit across the board. Questions inevitably start circulating internally about whether other critical infrastructure located elsewhere in the country might be similarly vulnerable to the same kind of coordinated attack. Resources that might otherwise have been allocated elsewhere suddenly get redirected instead toward reassessing and potentially rebuilding defenses around other high-value targets, spreading already limited military resources even thinner across an already strained and stretched national budget. It's worth stepping back here for a moment and thinking honestly about what this kind of coordinated operation actually represents within the bigger picture of modern warfare as a whole. This wasn't really a story about brute force simply overwhelming a defended position through sheer numbers or raw firepower alone. It was fundamentally a story about precision, careful timing, and exploiting very specific, very narrow windows of genuine vulnerability. Every single piece of this complex operation depended on something else happening exactly right, exactly on schedule, without any significant deviation. The radar deception had to work as planned. The anti-radar missile had to find its target the very moment the enemy system activated its own radar. The communication strike had to isolate the defending batteries at precisely the right calculated moment. The stealth aircraft had to hold their approach angles with absolute, unwavering discipline throughout. And the final weapons had to arrive within the same tiny fraction of a second to create the compounding structural damage the entire plan fundamentally depended on succeeding. Miss any single one of those critical elements, and the entire operation could have unraveled completely in an instant. A missed radar detection, and the formation gets tracked with enough precision to be genuinely engaged and potentially shot down. A failed jamming attempt, and a short-range missile system gets its clean shot instead. A slight timing error on the final weapon's release, and the tunnel survives with only minor, easily repairable damage instead of complete structural collapse. This is precisely why operations exactly like this one take months, sometimes even years, of careful, methodical planning before they're ever actually executed in the real world. Every single variable gets carefully studied, rehearsed extensively, and refined repeatedly long before a single aircraft ever actually takes off from the ground. There's also something genuinely worth understanding about the broader lesson this kind of strike teaches, one that extends well beyond this specific target or this specific country involved. Modern militaries all around the world have spent decades building increasingly sophisticated, increasingly integrated defense networks of their own. Radars linked directly to command centers, linked in turn to missile batteries, linked further to communication relays, all working together as one coordinated system designed specifically to detect and respond to threats faster than any individual component could ever manage entirely alone. That kind of deep integration provides enormous advantages under normal, everyday circumstances, but it also creates a very specific, very real kind of vulnerability hiding underneath the surface. A network is genuinely only as strong as its weakest, most critical link in the entire chain. Sever the right connection at exactly the right moment, and an incredibly sophisticated, expensive, and carefully built system can collapse into a scattered collection of isolated, uncoordinated pieces almost instantly. This particular operation demonstrated that exact vulnerability in genuinely devastating fashion. Iran had invested enormous resources over many years, building exactly the kind of layered, fully integrated defense network that modern military doctrine generally considers absolutely essential. Multiple radar systems providing overlapping coverage across the region. Missile batteries positioned at carefully staggered ranges to create genuine defense in depth. Communication systems specifically designed with redundancy built firmly in mind from the start. On paper, all of it looked genuinely formidable and well thought out. In practice, a small, precisely coordinated force found and ruthlessly exploited the specific seams hiding within that system seams that only become visible when someone studies a network closely enough, patiently enough, and creatively enough to actually find them in the first place. That's really the deeper story sitting underneath all the technical details about radars, missiles, and precision-guided bombs. It's fundamentally a story about how thoroughly an entire defense strategy can fail when an adversary understands not just what a system is designed to stop, but precisely how that system actually behaves under genuine real-world pressure. Every defensive layer involved in this operation did more or less exactly what it was originally designed to do. The long-range radar detected something unusual. The missile battery attempted to engage the contact. The short-range system achieved a genuine lock. Individually, each piece of that layered defense network functioned exactly as intended. Together, sequenced carefully against them with precisely the right timing and precisely the right countermeasures, they failed completely and totally. Think for a moment about the human element sitting quietly behind all of this advanced technology, because it's genuinely easy to get lost in the technical specifications and forget that real people were involved on every single side of this operation. Radar operators who had trained diligently for years, suddenly facing a real situation their own instructors had told them was nearly impossible to detect in practice. Missile crews who did absolutely everything according to their extensive training, only to watch their expensive weapons miss by wide margins through absolutely no fault of their own. Communication specialists who found themselves suddenly and completely cut off, unable to coordinate any longer with units they'd worked alongside closely for years. And on the other side, entirely, pilots holding perfectly steady through the very heart of an enemy missile's active engagement envelope, trusting equipment and training that had been rehearsed countless times before, but never actually tested under real conditions quite like this before. Every single one of those people was operating under enormous personal pressure that morning, making critical decisions in mere seconds that would end up being studied and carefully analyzed for years afterward by military planners everywhere. That's the genuine reality behind every major military operation, regardless of which particular side you happen to be looking at closely. Behind every piece of advanced hardware and every tactical decision made, there are real people whose training, judgment, and split-second choices ultimately determine exactly how events actually unfold on the ground. So what does all of this actually mean going forward from here? In the immediate aftermath, the practical impact was genuinely severe and completely undeniable. A major port suddenly and effectively cut off from any efficient overland transport whatsoever. Military resupply routes disrupted for weeks, quite possibly much longer, depending entirely on how quickly emergency repairs or workable alternative logistics could realistically be arranged. A significant portion of the country's overall economic activity suddenly forced through far less efficient channels than before. These aren't abstract, purely symbolic consequences existing only on paper. They're concrete, measurable disruptions that ripple steadily outward into every single part of a country's ability to function properly. From military logistics all the way down to ordinary economic activity that everyday citizens genuinely depend on each and every day. But there's also a longer-term consequence genuinely worth considering here, one that extends well beyond just the immediate physical damage itself. Every military planner watching this particular operation unfold, whether in Iran or genuinely anywhere else in the world, just received an incredibly clear demonstration of exactly how vulnerable even a carefully layered, expensively constructed defense network can ultimately be against a sufficiently sophisticated and patient enough adversary. That specific lesson doesn't stay neatly contained to just one country or one isolated region. It fundamentally shapes how military strategists everywhere think about defense planning, going forward from this point on, directly influencing decisions about redundancy, about communication resilience, and about exactly how much confidence to reasonably place in any single layer of protection, no matter how genuinely advanced it might appear on paper beforehand. For Iran specifically, the challenge going forward from here is genuinely significant. Rebuilding physical infrastructure, like a mountain tunnel or a river bridge, takes considerable time, often measured realistically in months or even years, rather than mere weeks. Rebuilding the kind of deep confidence that comes from genuinely believing your most critical assets are truly secure takes even longer still, and in some meaningful ways, may never fully return to exactly where it stood before this particular operation ever happened. Every future defensive strategy from this point forward will now be built with the lasting memory of exactly how quickly and how completely this particular network failed when it actually mattered most. Step back now and look honestly at the full picture of what actually happened here that morning. This wasn't a story about overwhelming force simply crushing a target through sheer size or raw numbers alone. It was fundamentally a story about understanding a system so thoroughly that its own defenders never truly stood a realistic chance, despite doing almost everything their training had told them to do correctly. Every layer of defense reacted exactly as it was designed to react. And every single one of those reactions had already been carefully anticipated, studied in detail, and countered long before the first aircraft ever even left the ground that morning. That's the real lesson genuinely sitting underneath the smoke and rubble left behind at that mountain pass afterward. Not that Iran's military somehow lacked capability or genuine dedication, but that even the most carefully constructed defenses inevitably have seams, and a patient, sophisticated adversary who studies those seams long enough will eventually find them without fail. The supply line Iran feared losing more than almost anything else didn't fail because of simple bad luck or poor training on the exact day it mattered most. It failed because someone else spent years quietly learning exactly how to make it fail, down to the very last second of perfectly synchronized timing. If this breakdown helped you genuinely understand just how much precision and careful planning goes into a single coordinated strike like this one, let me know in the comments. Which specific part surprised you the most? And if you want more detailed breakdowns exactly like this one, delivered regularly and covering stories most channels never bother digging deep enough to properly explain, subscribe right now so you genuinely don't miss what comes next. Thanks for watching, and I'll see you in the next one.